The next section is multiplying fractions, whole numbers and proper fractions. I'm going to do both in one video because I think they kind of just lead right into each other. So it might be a bit of a longer video again, like the last one, but hopefully not too bad. So multiplying represents repeated addition. Recall that, right? So 2 times 3 means 2 groups of 3. So we could say 3 plus 3, or we could say 3 groups of 2, 2 plus 2 plus 2, right? So multiplying is just like repeated addition. So we're going to take that concept and now we're going to apply it to fractions. So for example, if I have 2 times 1/3, here I have 1/3 and 1/3. I have 2 groups of 1/3s. So how much do I have? How many thirds do I have? Well, I have 1, 2. I actually have 2 thirds now. Okay? So I have 1, 2 groups of thirds are 2 thirds. You might think sixth, but that's not the way it works because we don't multiply. We just look at how many groups of thirds we have. Again, we have 4 times 3/5, so 4 groups of 3/5. So you could count them all. This is the slow way to do. I'll show you how to do the fast way in a second here, but this is the slow way. You'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 fifths. 12 fifths. Okay, so that's kind of, again, it doesn't work perfectly because fractions are a little more complicated than this, but it's like repeated addition. Sort of like repeated addition, right? And if I had a third plus a third, it would be 2 thirds because, again, when I add, I don't add the denominators, right? The denominators stay the same. Just like this, if I had 3/5 plus 3/5 plus 3/5 plus 3/5, it's 12 fifths because the denominator does not change when you add and subtract fractions. So we're gonna make a rule here. Before we go on, we're gonna make a rule. We're gonna put a 1 under the whole number as a denominator. Then we're going to multiply. And remember, when we multiply numerators by numerators and denominators by denominators. That's how we're going to work. That's how this works. So the numerators get multiplied together. Denominators get multiplied together. You do not need a common denominator when you're multiplying or dividing fractions, ever. Very simple. Much more simple than adding and subtracting. We did the adding and subtracting before. That's actually more complicated, more difficult, more steps involved than multiplying and dividing. Way fewer steps involved. So this section should be a little more streamlined. Okay? And we just multiply the tops by tops. That difference, though, is that we multiply the bottoms by the bottoms as well. Okay? Okay, so rule. Put a 1 under the whole number. That's step 1. So put a 1 under the whole number because 5 over 1 is the same value as 5. Next, what's the step say? What's that rule say? Oh yeah, then multiply the numerators together, then multiply the denominators together. So 5 times 4 is, of course, 20, not 26. So 20, and of course, we're always going to look at our final answer and see if we can reduce or simplify it too. 1 times 3 is 3. Change this to it's an improper fraction, so we'll change it to a mixed number, of course, like we did last lesson. So 3 goes into 20 6 times, because I know 3 times 6 is 18. And then I'm going to be left with 2 thirds. And I can't reduce the 2 thirds, so that's how it stays, 6 and 2 thirds. Okay, find the product of this. So I put it over 1, put the 1 in the denominator, and then I multiply the numerators together. So 4 times 1 is 4. 1 times 2 is 2. And I know that right away, 4 over 2 is actually the same as 2. Okay, because 2 goes into 4 2 times evenly with nothing left over. So 2 is my final answer. Okay, let's look at a quick word problem here. So if there are 15 students in a swimming class, and 4/5 of those 15, and 4/5 of them, remember, whenever we see the word of, that means multiplication for math. 4/5 of them are 13 years old. How many swimming students are 13 years old? Okay. So I'm going to take 4/5 of the 15. So if 15 students in the class, 4/5 of them are 13. So I have 15. Of means multiplication. The fraction I'm multiplying by is 4/5. So remember, multiplying with a whole number, step 1, put it over 1. Step 2, we multiply straight across. So 15 times 4, well, I know 15 times 2 is 30, so 15 times 4 is 60 over 1 times 5 is 5. And if you look at 60 over 5, I know that 5 is going to go into 60 evenly. and that is going to be equal to 12. Okay, so 12 students are 13 years old. Okay, that's my final answer. Okay, that's the end of part 1. So I just want to kind of get that out there. 5.1 is fairly simple. Just multiplying whole numbers by fractions. So you can see why I kind of combine these two. Because part 2 is going to use the exact same concepts from part 1. Multiplying proper fractions. So a proper fraction is when the denominator is bigger than the numerator. A half, 2/7, 4/5, so on. Improper fractions are the opposite. It's when the numerator is actually larger than the denominator. Of, as we just saw, means multiply. So, find the product. We're going to look at little diagrams. I'm not going to require you to do diagrams, to draw diagrams. I'm just using them as a tool to maybe help you visualize what's going on here. So a half of a half. I didn't color this in yet, but if I take this whole thing, and I would have this whole part colored in here, and then I take a half of that whole thing, so I cut this in half, what am I left with here in the top part? So again, let's do that again. So I cut this whole thing in half right down the center. What am I left with in one section? In one section, I'm left with 1/4, because now I've cut this whole thing in half. I have 1, 2, 3, 4 sections. If I'm looking at just one half of that, just the top half, I'm cutting it in half. How many portions are colored? 1 out of 4. Kind of confusing with diagrams, which is why I typically don't really use them. But again, maybe this will help some people visualize. 1/3 times, and times means of, 1/3 of 2/5. So the diagram I have here is 2/5. 1, 2, 3, 4, 5. 2 of them are colored. We're going to cut this into thirds. So I have 1, 2/3. And I'm going to look at one section, because it's 1/3 times 2/5. 1/3, only 1/3, not 2. So 1/3 of, or times 2/5, one section. I have 2 out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so you can kind of see how diagrams, we can cut diagrams up to solve multiplication of fractions. Not the best way to do it, but an okay way to visualize. Now let's look at some examples here. First of all, the rule. Just like before, we don't have to convert or put a 1 under because we're not dealing with whole numbers. But if you are dealing with whole numbers, put it over 1. Multiply numerators by numerators, then multiply denominators by denominators. Then, I should have written this before, simplify, if you can. If you can't, totally fine. But simplifying means changing an improper fraction to a mixed number, simplifying the fraction, reducing it, those kinds of things. Okay. Find the product. So, rule, I just multiply the top by the tops and the bottoms by the bottoms. Numerators and denominators. So 2 times 3 is 6. Over 3 times 7 is 21. Can I reduce that, simplify it? Is there any common factor between 6 and 21? No. So that is it. Next example. 3/4 times 8 over 9. So, just multiply straight across. 3 times 8 is 24. Over 4 times 9 is 36. I can see that both of these can be divided by 2 to simplify. They can actually be divided by something bigger, though. Because if I want to reduce this in one step right away, I don't have a lot of space for one, and I want to reduce it. Both of these are actually divisible by 12. So 24 divided by 12 is 2, and 36 divided by 12 is 3. I could show you a little trick that we could do before even going further to multiply. Right from here, right from the beginning. Don't pay attention to this if you don't really care. If you do care, you can do what's called cross divide. You've heard of cross multiplication. When you're doing multiplication questions, you can actually do what's called cross dividing. So I can look at the tops and the bottoms of each fraction and ask myself, does anything simplify first before I go ahead and multiply? So 3 and 9, yeah, there's actually something common between both of those. 3. So if I divide 3 by 3, I get 1. If I divide 9 by 3, I get 3. Okay? And actually just, again, skip this if you if you don't care. It's totally fine. You can just simplify at the end. 4 and 8, right? 4 and 8, you can simplify those because 4 goes into both. So 4 divided by 4 is 1. 8 divided by 4 is 2. Now this question becomes 1 over 1 times 2 over 3, which is really simple. 1 times 2 is 2. 1 times 3 is 3. No simplification needed at the end. Does it save time? Maybe not, because you have to simplify anyway at some point. But just a little trick. So 4 times 3, or you could just do the normal way. 4 times 3, which is 12. 10 times 8, which is 80. I can reduce both of these down. I could divide it by 2 first. So 12 divided by 2 is 6. 80 divided by 2 is 40. Then I could see I have to divide this again. I can divide them again, both by 2. So 6 divided by 2 is 3. 40 divided by 2 is 20. But again, before I multiply, if I look at the 4 and the 10, that can be reduced right away, right? 2 goes into both those. So I would divide by 2, divide by 2, so I get 2 over 5. But again, if I look at the tops, the cross division works between fractions, between the same fractions, between different fractions, all the time, right? So it's a really handy tool. So if I look at this 2 and this 8 on the bottom, they also can simplify. They can also both be divided by 2. So the 2 on the top now becomes a 1, and the 8 on the bottom, remember dividing by 2, becomes a 4. Now I have 1/5 times 3 over 4. 1 times 3 is 3. 5 times 4 is 20. It did require less steps, and I can actually squeeze it into a smaller space, which isn't necessarily the best idea, but it can work. So, just like I said, I already showed this actually, the hint. You can simplify before you multiply, cross division, right? So I already showed that above. I went through that whole example already. Okay, remember 4 divided by 8, 4 divided by, or reducing 4 and 8, reducing 4 and 10, cross dividing, and doing all that step. Okay, word problems. So, Mr. Howell, that's me, spends 1/5 of his time skydiving. I do not. While skydiving, he spends 1/3 of his time screaming. I probably would if I was doing skydiving, I would definitely scream. I'm deathly afraid of heights, so I would never do this. But Mr. Howell spends 1/5 of his time skydiving. While skydiving, he spends 1/3 of his time screaming. What fraction of his time is spent screaming? I assure you, I don't like skydiving. So this is clearly a multiplication question. You can see the words of all over the place. So we can see, oh yeah, multiplication, multiplication. So 1/5 of my time, of my entire time, times 1/3 of that time, which I'm skydiving. So what fraction of my entire time is my life is spent screaming? So multiply the numerators together. 1 times 1. Well, first of all, could I reduce anything? Could I cross divide? No, because these are very simple fractions. So 1/5 times 1/3. 1 times 1 is 1. 5 times 3 is 15. So 1/15 of his time is spent screaming, which again is not true. However, if I did skydive, I would probably scream quite a lot. Okay, last example here. And these are actual, this one I actually got statistics online. These are actual statistics from Canadian gaming, and I'm a gamer. I'm a PC gamer. I don't play Fortnite. My kids used to. So roughly 5/8 of all teenagers play Fortnite. This is according to the Survey Monkey done. There was a Survey Monkey done in 2018, not that long ago. According to Real Canadian Gamer, which was an online gaming statistic, 6/10 of teenage females consider themselves gamers. So we're going to try to figure out how many female teenagers play Fortnite. And I was trying to think of like a more kind of applicable question. So maybe this is applicable. So 5/8 of all teenagers play Fortnite. Of those, according to Real Canadian Gamer, 6/10, 6 out of 10 are teenage females who consider themselves gamers. So we're going to multiply again. 5/8 times 6/10. Let's do our little shortcut method. See if, I mean, you can multiply straight across. Go ahead, right? 6 times 5 is 30. Whoops, over 8 times 10, which is 80. Totally fine. Then reduce that fraction. But I'm going to go the shortcut method, and I'm going to simplify or cross divide. So 5 and 8, no, but 5 and 10, yep, both divide by 5. 5 divided by 5 is 1, 10 divided by 5 is 2. 6 and 2 I could reduce, or 6 and 8, or whatever. It's up to you, really. I usually do cross because then, I don't know, makes it kind of fun. So 6 and 8 both can divide by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Now I have completely reduced fractions. So 1 times 3, 1/4 and 3 halves. So 1 times 3, the tops, is 3 over 4 times 2, which is 8. So according to Real Canadian Gamer and the Survey Monkey done in 2018, two statistics I just kind of found online. This is maybe not accurate, but 3/8 of female teenagers play Fortnite. Okay? So kind of an interesting statistic, I suppose. So again, multiply straight across. How its multiplication is related to diagrams. Always multiply numerators by numerators, denominators by denominators. You do not need a common denominator at all for multiplying and dividing. It makes it much, much simpler. And always, always, always try to simplify your final answer if you can. Again, you don't have to use the shortcut method. You could just multiply straight across, getting 12 over 80, and then reduce. Okay? That's not a problem. Just don't forget to reduce. If you cross divide at the beginning, then you don't have to worry about that. Makes it a little bit simpler. You know, oh, I've already reduced. 3 times 8, of course, was 24 over 4 times 9, which was 36. And if you don't know how to reduce right away by 12, divide by 2, divide by 2. Keep like dividing it down smaller until you get to the most simplified that you can. No problem at all. Hopefully that helps. Let me know if you have any questions.